Assalamualaikum warahmatullahi taala wabarakatuh and a very good afternoon. Thank you, Mr. Chairperson, for kind introduction. Dear Excellencies, invited speakers and all participants. First of all, I would like to extend my sincere thanks to the OSI 2021 Organizing Committee, especially Dr. Bashir Kuzani, for inviting me to speak on the topic of deep seabed mining in Malaysia, opportunity and challenges. Actually, this paper is a joint paper with Prof. Dr. Wan Izzatul Asma Wan Talat from Center for Ocean Governance, INOS Universiti Malaysia Terengganu. The purpose of this paper is to explore the preparedness of Malaysia to embark on exploration of deep seabed mining in area beyond the national jurisdiction while observing the effect of deep seabed mining to the marine environment. And the opportunities and challenges in exploring the deep seabed mining as well as the relevant international and national law related to deep sea mining will also be discussed in this paper. So before I start with my presentation, I would like to a disclaimer. Any views given in this presentation are purely personal views of the author and do not represent the views of JMG or UMT or any party. So the outline of my presentation as projected on the screen, I will introduce what is the deep seabed mining. Then I will show where the area of the deep seabed mining. After that, I will discuss on the function of International Seabed Authority or ISA under United Nations. And the important part is law, regulation, and procedure before Malaysia embark on this deep seabed mining. And we will look at the opportunities and challenges. And after that, I will conclude my presentation. Lastly, but not least, is a way forward. Lately, strategic mineral mining such as rare earth element, REE, precious metal and deep seabed mining has received media and public attention, both internationally and locally. It's covered not only the resources and the importance of the mineral, but also the public's or NGOs' concern of the environmental impact on the mining. End of last year, if you remember, Kedah MB announced of the RE resource in the Kedah is worth 62 billion ringgit Malaysia, and you can see at the lower of the my slides, actually in 2018, Japan discovered of RE of Japan could secure 780 years of industrial demand. This is one of the biggest REE found in the offshore or deep sea. And as we aware that in near future, deep sea mining might be turned one of the turned in ocean in the new industrial frontier. This graph show how the global mining industry affected by the COVID-19 pandemic, as we aware that the first disease outbreak COVID-19 somewhere in last year in January 2020, and no, actually the first case is 2 January in 2020. Then in this year, as we know that somewhere in March, and you can see that from the slide there is a short term actually. As we can see that the short-term affected after declaration of COVID-19 pandemic somewhere in March 2020. And if you can see that the green, the blue, the gray and the brown graph line show that the gold, platinum and palladium trend during the before and after the COVID-19, you can see that there is not much change actually compared to the the to the oil and gas, which is shows in the green line, which is stated there, Brent crude. So since the mining activity is considered as essential services, it is not much affected compared to oil and gas industry. So actually, why lately many countries venture in the deep sea mining? So one of the reason is the mineral industry is expanding fast, coincide with the increase in demand. So actually, as you can see, that global economic growth, supply and demand, population and consumption increase with the industrialization and urbanization. And the second is the depleting, actually deficiency of the land mineral, which is depleting base mineral, has led to the seeking of mineral resources, especially from the deep sea. And another important part is now new users and market to promote actually the green and blue economy, especially now under United Nations. They are promoting the green economy and blue economy. And also deep sea mineral have high concentration of the precious metal, which is compared to the land-based mineral. A lot of country has started to explore and exploit the deep seabed mineral. Thus, it is necessary for Malaysia to commence on deep seabed mining, exploring to reap its economy and technology benefits. And on top of that, one of the reason is to secure the state in terms of the financial, economy and technology. So for Malaysia, I think Malaysia aims to be a high technology country, and it is essential to have a continuous supply of mineral. With the depletion of the land-based mineral, mineral found in the deep sea should be explored and mined. So actually, what is the deep seabed mining? It's actually is a deep seabed mining means a mineral extraction or mining process in the deep ocean floor. Why we want to embark in the deep seabed mining is, as I mentioned just now, one of the reason is for the new resources of the minerals such as polymetallic nodule, cobalt-rich ferromanganese crust, polymetallic sulfide, and the new coming mineral is REE. And also the all this mineral is highly concentrated actually, especially in the world, especially to the world high-tech industry, such as in the cosmetic, smartphone, tablet, electric car, and wind turbine. Where we can find this kind of mineral. Actually, the term that we use is area, which is determined and regulated by the International Seabed Authority. We can, in short form, we call ISA. It is an international organization under UNCLOS 1982 under United Nations. So many countries have been granted license by the ISA to explore and exploit actually for prospecting in the area beyond the national jurisdiction, which is we call that area for the deep sea bed mining. So the top 6 countries given the most contract by ISA are Russia, China, Germany, France, Republic of Korea, and Japan. So now I would like to share actually where actually deep sea mineral occurrence. So the occurrences of these different type of deep sea mineral is principally controlled by the geological and tectonic setting, and also bathymetry of the seabed area. As you can see that on the slide, you can see that seafloor massive sulfide, which is we can found in the area backyard basin and also in the trench and the mid-ocean regions. But for manganese nodule, we can found in the ocean floor, which is the depth of the water between 4,000 to 6,000 meter. And the third one is cobalt rich crust, where we can find the mostly in the seamount area. Normally water depth between 400 to 4,000 meters. So as we know that REE is one of the new strategic mineral and highly demand, especially in the IR 4.0 industry. So normally this RE element contain 17 element, as you can see that from scandium up to the lithium, one row. And this mineral actually widely used in cell phone, in car, and most of them or some of them are very expensive. As you can see that the table below on the right hand side shows the price of the REE. So you can see that the price actually ranging from 7,000 to up to 2 million actually per metric ton. And on top of that, actually REE or rare earth element is one of the strategic mineral and highly demand used in the defense industry and also in the very high technology industry. Next. So now I move to my second part is I will discuss on the what in the area, actually what is the area for the deep seabed mining. So under Article 1 UNCLOS United Nations stated the seabed and ocean floor and the subsoil thereof beyond the limit of national jurisdiction actually refer to an area under the International Seabed Authority ISA. So you can see that the provision very clearly under the Article 1 United Nations shows the definition of the area and governs by the ISA in the left hand side. But for the state jurisdiction is under territorial sea, which is 12 nautical mile, EEZ 200 nautical mile, and continental shelf, which is up to 300 nautical mile maximum. Actually is including the extended continental shelf is under the state jurisdiction. So it's you can see that most of the deep seabed area is actually under the ISA. Next. So actually this figure shows the maritime zone, and the rights is under UNCLOS 1982. So it shows that the area of a common heritage of the mankind under ISA jurisdiction. You can see that the last portion of the cartoons show the area which is under the ISA. And you can see also the general geology profile of the seabed from this figure. So actually the common heritage of mankind principle in the United Nations Convention on the Law of the Sea UNCLOS allow us to do this in the way that ensure access for all and equitable distribution of the benefit. So actually that's why all the mining, the deep sea mining area is managed by the ISA, which is under United Nations. So actually under ISA, deep seabed mining under ISA, there are 5 main area and different type of mineral found for the deep sea mining. As you can see that the first one of the famous area is Clarion-Clipperton fractured zone, which is we can find the polymetallic nodule. Second is India Oceans. We can find polymetallic nodule and polymetallic sulfide. Third is mid-Atlantic ridges. Normally, we can find polymetallic sulfide. Southern Atlantic Ocean, which is we can find cobalt ridge and ferromanganese crust, and the last one is in the Pacific Ocean, which is a polymetallic nodule, cobalt ridge, ferromanganese and crust. So actually, this map show the exploration license already granted to the several countries by ISA in the Clarion-Clipperton zone for the polymetallic module. So this is one of the famous area for the deep sea mining. And you can see that in the one of the area actually owned by our neighbor Singapore, already got the license under Ocean Mineral Singapore Mineral OMS, actually marked in green color. You can see in green color actually is area owned by the Singapore. Next. So this map shows the exploration license in the India Ocean area for the polymetallic nodule and polymetallic sulfide. You can see that a few countries, especially Russia, China, Korea, and India. And there is still a reserve area which is marked in yellow color. So we hope that Malaysia will be able to get the to apply for the area in near future. So this map shows the exploration license in the mid-Atlantic regions exploration area for polymetallic sulfide. Actually, there is 3 countries in this area. So this map show the exploration license in the Pacific Ocean area for polymetallic nodule and cobalt-rich ferromanganese crust. Next. So this map show the exploration license in the South Atlantic Seamounts exploration area for the ferromanganese crust. And now I move to the third section is for I will share what is actually the ISA. So the ISA is stand for the International Seabed Authority. It's an intergovernmental body based in Kingston, Jamaica. It was established in 16 November 1969 to organize, regulate and control all mineral-related activities in the international seabed area beyond the limit of national jurisdiction, an area underlying most of the world oceans. Since the ISA has continued to evolve as it begins to implement all the aspects of its broad mandate for marine scientific research, capacity building, and regulator of the seabed mining. So actually, there are main body. There are 4 actually. The main body is Assemble, Council, Legal and Technical Commission, Finance Committee, and Secretariat. Then the second is the Assemble, which is consists of all member states. 168 UNCLOS member state and set general policy for the authorities ISA. So the council consists of the 36 member states elected by the Assemble and is the executive body to discuss a substantive matter. Then LTC is under Article 169 evaluate application, supervise contractor and provide regulation for council consideration. And actually all 4 bodies meet annually at the ISA headquarters in Jamaica. So now the Secretary General is Michael Lodge from the United Kingdom. And as for the budget, actually ISA has the biennial budget for the 2020 is USD 71 million. And Malaysia, as a party state since 1984, has paid the working capital fund of the International Seabed Authority. Is amount 28,000 USD in 2018 and in almost 39,000 USD in 2019. So this map shows the 30 ISA contracts for the explorations. As you can see on the map, we hope that Malaysia will be put one on the map in near future. So now I will move to the law, regulation and procedure, which is related to the deep sea mining. So being a state party to United Nations Convention on the Law of the Sea and Convention of the Biological Diversity in 1984, Malaysia has yet to develop a set of policy, regulation and law related to deep sea mining to mitigate its effect on the marine environment, coinciding to the requirement of this convention. So one of the requirements for the state to explore actually for the deep sea mining, the state must have legislation with regard to the seabed mining, which comply with the obligation established by the UNCLOS and ISA Mining Code. This has been stated in Article 939 under the Part 11 of UNCLOS 1982, Annex 3 of UNCLOS 1982, and the ITLOS Advisory Opinion 2011. This is actually to ensure them to have an effective implementation and enforcement of the administrative measure to conserve the marine environment, and the legislation then must be read together with the other international legislation such as the Convention on the Biological Diversity 1982 in order to protect the marine biodiversity. So actually the most important is requirement to explore deep seabed mining. Actually the state must have a deep seabed mining legislation which comply with the UNCLOS 1982 and its mining code. So this actually what is the deep seabed mining legal framework provision or the DSM legal framework must have the provision which is comply with the Article 139, 208 and 209 UNCLOS to avoid pollutions, cover within and beyond national jurisdiction, and the DSM should outline operators' responsibility to safeguard marine environment to ensure compliance and liability for damage. And also the DSM legal should has the high-tech knowledge and equipment to avoid habitat destruction, to ensure minimal threat to sensitive or vulnerable species, and the last but not least, to ensure zero or minimal impact to the fisheries resources. So this flow shows the procedure actually to explore the deep seabed mining. So the contractor must first identify a type of the deep seabed mineral and part of the area to explore. Then after that, apply for approval, normally for 15 years plan of work for exploration in the contract form, which is the contractor must include the specific and sufficient information of the financial and technical capability of carrying out the proposed plan of work. Then the proposal also include a general description and schedule of the proposed plan of the work. The contractor must come up with the program of the activities for the 5 years period, which is including the research and study that will be done in the respect to the environmental aspect, and also possible impact of the exploration activity to the marine environment. And finally, the contractor must propose measure for the prevention and control of the potential environmental impact. So I move to the the opportunity and the challenges in order to embark on the seabed mining. So for the opportunity, actually, as I mentioned just now, deep seabed mining will mean sustainable production for the future resources. Second is mineral concentration on the ocean floor is far greater than compared to on land. Third, to ensure the supply of metal for use in the efficient and clean technology and reduce the footprint of the mineral extraction. Fourth is environmental impact of the deep seabed mining would not be as severe as that one on the offshore area. Deep seabed mineral are world-class resources of mineral for the development and industrialization. As I mentioned just now, the REE found in the offshore of the Japan, and as one of the source of enormous wealth, especially for the blue economy. Next. So for the of course we have so many challenges in order to success or to start explore for the deep seabed mining. So one is need to develop management regime to govern seabed mining activities. As I mentioned just now, we need to have the proper setup, governance. Second is required high-end technology equipment, machine and ships. So third is have to establish and implement new policy and law. Fourth, companies seeking to engage in the seabed mining activities in the area of national jurisdiction will operate subject to policies and law. Fifth, could have serious impact on the ocean environment and well-being of the coastal communities. Sixth, extremely high-cost exploration. Next. So as for conclusions, so having the legislation in place would be would overcome the first hurdle actually before we start to embark on the seabed mining. Second, a special committee which is comprises of the researchers, government and stakeholders, including the affected population, should be established. Third, the expertise, technology and the financial issues need to be resolved. Only then would Malaysia be ready to embark on extensive deep seabed mining. Fourth, Malaysia must establish its own deep seabed mining laws, which is this is a very critical one. It is essential to have comprehensive governance framework, including policies and administrative measures to ensure effective implementation and enforcement, particularly in matters related to the health of the marine environment. Lastly, but not least, Malaysia would be ready to embark on the deep seabed mining if this issue can be resolved. Next. So, for the way forward, actually, as I mentioned just now, before we start, so we should have the funding, because as I mentioned just now, for the deep seabed mining, we need at least 1 billion ringgit Malaysia. So this is the issues that we need to discuss, whether this funding should come from the private sectors or from the JLC or from the company, or I think if from the government, it is impossible for government to fund 1 billion for the deep sea mining to start. The second is the technical expert. Of course, we need the technical experts to do the study and so on. Third is the governance framework, which is including the laws, regulation, and how we want to manage the deep sea bed mining. Fourth is the database. This is the one that important because we have the very big data during our exploration and so on. And the fifth is the coordination for the inter-agencies.